Welcome Algebra Tuesdays to the homework up video pages 438 and 409. Let's jump right into this. Let's solve some logarithmic equations. Here we go. Let's take a look at the first section, 29 through 45. We're going to solve this logarithm. Obviously, step one is to isolate the logarithm completely. We underline the word, the logarithm itself. We underline the word log, or we circle it, whatever, and then we also circle the argument or underline it, whatever, and then everything else should be gone, so it's totally isolated, okay? Step one is isolate the logarithm. Step two is to write it exponentially, so my base is right here. If I wrote this exponentially, it would look like this. X equals e to the 4 power. So x equals this right here. Type this into your calculator, e to the 4th power. You would hit your E button, and then this would pop up, and then type in 4, and then hit enter, and you will get this right here. So step 1, isolate the logarithm. Step 2, write it exponentially. Step 3, solve. And then lastly, always check your answer. Always check your answer. Remember, take your answer and put it in the original argument, and make sure it's positive, and of course it is. Moving on to 31. Step 1, isolate the logarithm. Well, here's the actual log part. Here's the argument. It's totally isolated. Step 2, we're going to write it exponentially. So 2x equals 10 from this right here to the 1.5 power. Alright. Now, in order to get x by itself, we would divide both sides by 2. So x equals 10 to the 1.5 power divided by 2. Okay? Now lastly, I would simply type this into my calculator. Okay? So what I would do is I would type in 10, and then here's my exponent, arrow, and then 1.5, and then hit enter, and then divide it by 2, enter, and you will get this out right here. Now always check that in your answer. So where x is right here, we're going to substitute 15.8. Now if I take 2 times 15.8, will my entire argument be positive, or will my entire argument be negative? Well, it'll obviously be positive, which is good. You never want a negative argument. Number 33. Step 1, we're going to isolate the logarithm. Well, here's the logarithm part. Here's the argument part, so I've got to get rid of this 4. If we divide both sides by 4, we're left with this. Pretty simple. Step 1 is done. Step 2, write the equation exponentially. So now I have x equals 3 to the 7th power. Step 3 is solve, and of course x equals this. You would type in your calculator 3, arrow, 7, hit enter, and you will get this right here. Now we've got to check that in our answer. So where x is, I put 2,187. When I do that, do I have a positive or a negative argument? Obviously positive, so we're good. You never want a negative argument. Okay, moving on to number 35. Step 1, isolate the logarithm. So here's the actual ln part, and here's the argument part. I've got to get rid of a negative 2 and a positive 1. Remember, always get rid of your multiplying number last. And this negative 2 right here is multiplying times the natural log, so we're going to get rid of it last. This is a positive 1. Don't let this sign confuse you. This is the sign of the 2, okay? Your 1 is positive, so bring it over and make it negative. Negative 2 logarithm of x equals natural logarithm of x equals negative 5. Next, we're going to divide both sides by negative 2. That would leave us with negative 2.5. Now, I don't mind putting a decimal as long as it terminates, but if it rounds or continues on, I like to leave it a fraction, but negative over a negative, it should be positive. My fault. Negative over a negative is positive. 5 over 2 is 2.5. So step 1 is done. We've isolated the logarithm. Step 2, we're going to write it exponentially. Don't forget a natural logarithm has a base of e. So if I write this exponentially, it's going to be x equals equals e to the 2.5 power. Well, if you type into your calculator e, hit your e button, this will pop up. And then type in 2.5 and then hit enter. You will get this right here. Now, if we put that in for x right here, 12.182, obviously our argument, 12.182, our argument will be positive, and that's what we want. So the answer does check out. Alright, number 37. Alright, now first of all, we have to do step one, which is to isolate the logarithm. Alright, so I'm going to circle my logarithm, the word logarithm. I'm going to circle my argument. Everything else has to go. This has to go, and this has to go. So here we go. First of all, get rid of the positive 7, make it a negative 7. So I'm left with 2. Natural log of negative x equals 7. Next, divide both sides by 2. And I'm left with the natural logarithm of negative x equals 3.5. Have I isolated the logarithm? Yes, completely. Step 2, write this exponentially. So my base is an e, even though you can't see it. So I would have negative x equals e to the 3.5. Now, hold on before you start typing that in. X is not by itself yet. There's really a negative 1 there. So we've got to divide both sides by a negative 1. So now x equals e to the 3.5 power all over negative 1. So here's what you would type in. You would type into your calculator e, and of course this would pop up, then type in 3.5 and hit enter, then divide it by negative 1, enter. And if you do that correctly, I'm looking for the answer you're going to come up with, negative 33.115. Okay, now that might be the answer. It might not work. It might be no solution. So let's see. Here's my original equation right up here. Alright. Now, where the x is, I've got to substitute my answer right here. So notice you have a negative sign already, so it's negative. And then you're putting in a negative 33.115. So that makes your entire argument become positive because you have a negative here. Plus you're putting into x a negative number. So a negative gives you a positive. So your argument is positive, thus the answer does work. Number 39. Alright, step 1, we're going to isolate the logarithm. Now here's the actual logarithm, the word. Here's the argument. We have to get rid of this 3 right here. So we're going to divide both sides by 3. And we're left with the logarithm base 5 of 5x equals 3. Step 2, write exponentially. So now I would have 5x equals 5 to the 3rd power. Next, I want to solve the equation, so divide both sides by 5. And x would equal 5 to the 3rd power divided by 5. So with the calculator, type in 5 to the 3rd power, that's 125. And then 125 divided by 5 is 25. Now, check that in the argument right here. So we'll put a 25 right here. 5 times 25 is 125. That is a positive 125. So my argument's okay. It is positive. So the answer is correct. Alright, moving on to number 41. Step 1, we're going to isolate the logarithm. Now here's the word logarithm right here. And here's the argument. So I have to get rid of a 2 and a 15. So first we're going to bring the 15 over and make it a negative 15. It was positive. That leaves us with 2 logarithm base 2 of x equals 16. Next, divide both sides by 2 to get rid of this 2. And that leaves us with logarithm base 2 of x equals 8 divided by 2. Divided by 2. Now, the logarithm is finally isolated. So moving on to step 2 now. We're going to write this exponentially. Alright? We're going to write this exponentially. So I would have x equals 2 to the 8th power. So obviously with your calculator, if you type in 2 to the 8th power, you're going to get 256. Now check that answer, make sure it works. The only x up here I see is this x right here, so for that x I'm going to put 256. And my argument is positive, so this answer does check. Number 43. Step 1, isolate the logarithm. So I'm going to circle the actual word logarithm and circle my argument. I've got to get rid of this number and this number. We'll start with the negative 5 first, bring it over and make it a positive 5. So now I have 2 natural logarithm of 3x equals 10. Next, divide both sides by 2 to get rid of this 2 right here. And I'm left with the natural logarithm of 3x equals 5. There, the logarithm is finally isolated. Step 1 is done. Step 2 is going to be to write the problem exponentially. So let's write this exponentially. Don't forget the base is e, even though you can't see it. So 3x equals e to the 5th power. Next, we're going to divide both sides by 3. So divide both sides by 3 and you're left with this right here. Now with your calculator, this is how I would type it in. I would type in your E button, natural base E button, and this will pop up. Then type in 5 and hit enter. Be sure and hit enter, and then divide it by 3, enter. And you will get 49. Of course, this is not exact, it's rounded, but 49.471. Okay, now if we put that into our argument right here, everything's going to be fine because we have a positive 3 and we're putting in a positive number. So when you take a positive 3 times a positive 49, you will have a positive argument, which is what you need. Alright, so this does work. Number 45. Alright, step 1 is to isolate the logarithm. I'm going to circle the word logarithm and circle my argument. Now, negative 3 is not part of your argument, guys, unless the problem looked like this. Then it would be part of your argument, okay? So here's my argument. So I've got to get rid of a negative 3 and a positive 10. So I'll bring the negative 3 over and make it a positive 3. So I'm left with 10 natural logarithm 100x equals 20, or 120. Now divide both sides by 10 to get rid of this 10 right here. And we're left with the natural logarithm of 100x equals 12. Okay? Now, my logarithm is finally isolated. So step 2 is to now write this exponentially. So if we're going to write this exponentially, don't forget there's a base e right here. So we have 100x equals e to the 12th power. Now divide both sides by 100 to get x by itself. And you're left with this right here. So with your calculator, I want you to type in e to the 12th power. Hit your e button, this will pop up. Type in 12, then hit enter. Then divide it by 100, enter, and you will get this right here. Okay? Now if we put that in for x right here, 100 times x, a positive 100, times a positive number will still give us a positive argument. So this answer is totally fine. Now moving on to the other page, I'm not sure what page that was. 403 maybe, it seems like 409. Page 409, we're going to do these numbers here, okay? Now, still have logarithmic equations, so nothing changes. Number 1, isolate the logarithm. It's isolated. Step 2, write the problem exponentially. 81 equals 3 to the x. Alright? Now students, would you please listen to me carefully. When you look at this logarithm here, you've written it exponentially. You now have an exponential equation. That did not happen in any of these other ones. Notice in all of these other problems, when you wrote the problem exponentially, your x, are you listening? Your x was never in the exponent in none of these. None of them. Go back and look. None of them. exponential equation. Okay? And so how do we solve this? Well, you guys know. First of all, you try to write both sides with the same steps or the same base. And we can do that. 3 times 3 is 9, times 3 is 27, times 3 is 81. So, 3 to the 4th power equals 81. So for 81 right here, I'm going to put 3 to the 4th power equals 3 to the x. So obviously x has to be 4 because 3 to the 4th equals 3 to the 4th. So the answer is 4. And there's really no need to check this answer because there's no x in your argument, so you know for sure your argument's going to be positive. It's going to stay positive. So the answer is 4. Number 49. Okay, step 1, isolate the logarithm. We've already done that. It's done for. Step 2, write it exponentially. So x equals 6 to the negative 1 power. Okay? Now if you type that into your calculator, I don't have one with me. Well, yeah, I do. If you type that into your calculator, 6, and hold on a second, guys. I'm turning my calculator on here. If you type into your calculator 6 arrow negative 1, you'll get this right here. 0.16, and the 6 is repeating, so 0.16 repeating. That's fine. Another way to do this, 6 to the negative 1, you guys know this. 6 to the negative 1, put it over what? 1. Bring the 6 down to the bottom. So the 1 becomes positive. Nothing left up top, so put a 1. So 1 over 1 times 6 to the 1. Well, that's 1/6. And 1/6 is the exact same thing as 0.16. Now, notice in my argument I do have an x. Do you see that? In my argument I do have an x. So I must check my answer. So pick up your answer, put it right here. Does my argument stay positive? Yes, it does. Positive 1/6. Number 51. Step 1. Isolate the logarithm. And it's isolated. Step 2. Write this exponentially. So x equals 3 to the 5th. Well, that's it. We're done. 3 to the 5th power is 243. Does my argument have a variable in it? Yes, it does right here, x. So you must check your answer. Put 243 right here. And my argument stays positive, so we're good. The answer is 243. Alright, moving on to number 53. Isolate the logarithm. We've done that already. Step 2, write this exponentially. So 64 equals x to the 3rd power. Now this is not an exponential equation because your unknown is not up here in the exponent. We know how to solve an x cubed problem. We've done some of these, guys. We know how to do this. If you have x cubed and you want to make it an x, take the cube root of it. But if you take the cube root of one side, you must take the cube root of the other side. Now remember, there are two things that have to take place in order for you to put plus minus. Number 1, you have to be the one that inserts the radical. And let me ask you a question. Was there a radical right here? No, there was not. So did you choose to insert the radical? Yes, you did. So number 1, you insert the radical, which we did, but number 2, the index has to be even. And the index here is 3, so we do not put plus minus. Do not do that. You only put plus minus when both of these are true. Now number 1 was true. You did insert the radical, that's true. But was the index even? No. So you do not put a plus minus. Now, the cube root of x cubed is x, and the cube root of 64 is 4. Alright, so there's your answer. And by the way, your base in a logarithm can never be negative either. Your base in your logarithm can never be negative. So just so you know, that could not, if the answer would have been negative 4, you cannot put a negative in here, okay? I'm not sure if we've ever talked about that before, but the base of a logarithm cannot be negative. That's just by definition. Alright, moving on to number 55. Okay, step 1, isolate the logarithm. We've done that. Step 2, write this exponentially. So 256 equals x to the 8th power. Alright, So now I've got to solve the equation. Now notice, we do not have an exponential equation. If we had an exponential equation, then this would be, the x would be up here, okay? We have an equation that we can solve by taking the 8th root of x to the 8th. We have x to the 8th, we want to get rid of that 8, so take the 8th root of it. However, if you take the 8th root of one side, take the 8th root of the other side. Now, first of all, let's go back to our last page. Did you insert the radical? Yes, you did. You chose to put it in. Is the index even? Yes, it is. So you do put plus minus here, okay? Now, the 8th root of x to the 8th is just 8, or excuse me, just x. How do you type this into your calculator? Do you remember, guys? Well, we hit 8 first. Make sure your screen is clear. Then push 8, and then math, and then my calculator's not in front of me, but I believe it's option 5. It's the option that looks like this. It has an x and then a radical like that. So you type 8, then go to math, then option 5, and this should pop up on your screen. And then type in 256 and hit enter, and if you do, you'll get 2. So don't forget the plus minus, positive, negative 2. So there's your answer. You know what? Maybe that's our answer. Let's see, okay? Let's see if it is, because look at the answer up here. It says just 2. Well, let me show you why. An argument can never be negative, so when you go to check your answer, you can definitely put a 2 here. That's fine, but negative 2 does not work, because now you have a negative base. A logarithm cannot have a negative base, alright? So, keep that in mind, guys. Negative cannot be part of our answer. So, the answer is just 2. We do not need a negative. Positive 2. Alright, 57. Step 1, isolate the logarithm. Well, here's the word log. Here's the argument. So it's totally isolated. Step 2, write this exponentially. So x plus 1 equals 2 to the 1 power. 2 to the 1 power, of course, is just 2. Bring the 1 over and make it negative, and x equals 1. Now let's check and see if that's right. Put a 1 in for x right here. 1 plus 1 is 2, right? So your argument is positive 2. So your argument is still positive, which is good. That's what you need. Alright? So, 1 would be the answer, because 1 gives you a positive argument. Alright? And that's it, guys. I hope this homework help video has been a help to you guys. If you have any questions at all, never hesitate